This is the part where I want to show you how to using double angle formula, right? As I already introduced what's a double angle formula, and from this you have to prove this is identity is true, right? Or you can see that from this one you have simplified become a tangent theta. So you have to prove from the left hand side that you're showing that you can getting the tangent theta. So as we know that we see that there is a double here, right? The double, there's a single, there's double here. So I think we should using double angle formula. So as you know that double angle formula for sine 2 theta is 2 sine theta cos theta, only one. But for the cos 2 theta, we have two types. We have three types. We have cos square theta minus with sine square theta, or we have 1 minus 2 sine square theta, and we have 2 cos square theta minus 1, right? For cos 2 theta, you have to aware which one to use, right? So now let's look at the left hand side here, right? Left hand side, so which is sine theta plus with sine 2 theta over with 1 plus cos theta plus with cosine 2 theta, right? So as you know that sine theta, right? Sine theta, nothing to do, so because it's a basic, so sine 2 theta you can replace with 2 sine theta cos theta, right? For this one you can using formula, and this one 1 plus cos theta, so you just write 1 plus cos theta plus with then this one is the one that you need to decide what to use there, right? Always observe the final the right hand side, which you see that tangent theta is actually sine theta over cos theta, right? So means on the denominator finally you need to get a cos theta here. You need to have a cos theta here. So what to do now is I have to try. I'm not going to use the first one, as I know that there is a mix of cos and sine here, right? It's so confusing. So I think there is a 1 here, right? So that I can eliminate the 1 here. The purpose is I want to throw away the 1 here. How to eliminate the 1 here? So I must have a negative 1, right? Yes or not? So if you have this one inside here, try to imagine if you have cos 2 theta as 2 cos square theta minus 1, then the 1 you will eliminate, right? So I think should be correct. So I just apply, right? You can just try. Okay, minus 1. So, and for this, okay, let's just rewrite sine theta plus with 2 sine theta cos theta, right? Over with this one 1 minus 1, you have 0, right? Easy. So then you have cos theta plus with 2 cos square theta, right? But we still can't see how from here to getting the tangent theta, right? Theta, right? So we look at here. We try to factorize. You have sine theta as a common factor, right? So we take out the sine theta. So inside you still have 1 plus with 2 cosine theta, right? And look at the denominator, because you see there's a sine over cos here, right? Cos. So means that I think cos theta and cos square theta, you have a common factor, which is cos theta. So you have 1 plus with 2 cos theta. You see, cos theta, 2 cos square theta. Now you can see this 2 is a common factor. Then we can eliminate. So now you're getting sine over cos. Then finally you have tangent theta, right? This is the way you prove. So you need to choose a right choice, okay? So that you can getting what you want. So let's move on with the second examples in the same video. Okay, let's continue proving this identity. Cotangent A plus tangent 2A is the same as the equivalent to cot A secant 2A, right? So I prefer from the addition to the product. So now, left hand side, we have cotangent A plus with tangent 2A, right? So in this case, I'm not going to using the double angle for tangent 2A, as I see that there are no tangent, there's cotangent here, but there are secant here, right? There are secant 2A here. So means that the tangent, you have sine over cos 2A will be more suitable compared to using the double angle for tangent 2A. So because there is still a 2A there, right? Means that this thing, they are actually not really using the formula for tangent to A. So as you know that double angle formula, you have sine A, which is 2 sine 2A, which is 2 sine A cos A, right? And the cos 2A, you will have cos square A minus sine square A, and 1 minus 2 sine square A, 2 cos square A minus 1, and another one will be tangent to A, which will be tangent to tangent A over 1 minus tangent square A, right? So I don't think so they're using this formula because the 2A is still appeal finally, right? So I think I should write this tangent as sine over cos and cotangent as cos over sine A, and tangent 2A as sine 2A over cos 2A, right? Then you can see that there is a cos 2A here, right? Because 1 over cos 2A, you are getting secant 2A. Okay, never mind, we just try. Now we are multiplying. We want to combine these two fractions, so I have to multiply this with sine A. On top also you multiply with sine A, and for this you multiply with cos 2A. Numerator also multiply with cos 2A. Okay, let's see what happened. Alright, then you have cos 2A, cos A, right? This is the angle larger, so I put in front, cos A, cos 2A, and sine 2A, sine A, right? So everything over with sine A, cos 2A. Yes. Alright. Then you have to believe that you are getting what you want. Right? So you have to try using the formula. So, okay, let's see. If you see that this one is very familiar to compound angle, right? The angle is different and they have a cos, cos, sine, sine, right? So I think I'm going to apply the formula for cos A plus B, which is cos A compound angle formula, right? In the previous video, you have learned cos A cos B minus with sine A sine B, but I don't think so I will using the minus one, the plus here, because there is a plus here, right? So if plus here will be minus, right? As I know. So now this is your so now this is 2A and this is your A, right? Cos 2A cos A, and this is sine 2A sine A. So the A here is actually 2A, so you can rewrite this one as equals to cos of something minus with something, A minus B, so that you can getting addition here, right? So the A will be 2A, and this will be your the other one will be your B. Your B is A, right? Because you have A, B cos A, sine A, sine B, right? So means your A, B is A also, 2A, A divided by sine A cos 2A. I think finally from the top I'm getting 2A minus A, I have cos A over with sine A. So cos A over sine A, and this one also you have 1 over cos 2A. Very clear right now. Cos A over sine A is cotangent A, right? Cotangent A. 1 over cos 2A is actually secant 2A. You have finally proved this identity is true, right? Okay, let's move on. That's all for this example. You are proving by using the double angle formula.